Hi, so today we're going to go through 3.7 applications. So one thing we can talk about is if I had an equation, let's say 7x equals 1, and I said solve it, obviously you're going to say 1/7. What if I said, okay, solve that, but your answer has to be an integer? You're going to laugh at me and tell me, no, there's no solution. However, if I said instead, well, what if I had the equation 7x is congruent to 1 mod 34? Well, this does actually have a solution. And I can see that the solution is 5. By inspection, like I can just guess at it. But let's say, why is it 5? Well, since 7 times 5 is 35, but mod 34, remember, just the idiot's way goes a long way for this. Just subtract 34 and we get 1 mod 34. So that means that solves that equation, x equals 5. Then technically there's infinitely many answers, like 5 works, 39 works, like I can keep adding 34, and any of those will work. So what's the point? Well, if I want to solve, let's say 7x plus 3 is congruent to negative 25 mod 34. Well, how are we going to do that? Well, I mean, the first part is okay. I mean, nothing changed. I'm going to subtract 3 on both sides. Okay. And I'm going to end up with 7x is congruent to, well, negative 28 mod 34. Well, I don't want to have numbers that are anything other than something between 0 and 33. So I'm going to add 34 to this negative 28 to correct it. And when I do that, I get 6. Okay, and now here's the tricky part. I know you want to say that we're going to divide by 7, but that's not really one. You can't say division because we're dealing with modulus, so there is no division. That's like a forbidden word. But what we really want to say is, well, you multiply by the inverse of 7 on both sides. Whatever that is, that's what would get rid of the thing on the left, and you would just have 1x equals something. Okay, well, what is the inverse of 7? We actually know that. It's 5. And the reason it's 5 is up here. Well, 7 times 5 is congruent to 1 mod 34. So, really we can just think of this as 7 times 5 is 1. That means 5 is the inverse of 7, and 7 is the inverse of 5. So, I can just write it out. 7 inverse is 5 mod 34, and 5 inverse is 7 mod 34. Well, knowing that, now we can just replace this as 5 times the 6, and 5 times 6 is 30, Well, we don't need to correct that. That's already between 0 and 34, or, oops, 0 and 33. So we're good. That's our answer. Well, here's the problem. What if we had 3x plus 5 equals 1 mod 7? Well, now this is a much different problem. I mean, I can go the first step of subtract 5 on both sides, fine. And I'm going to get negative 4 mod 7. And I can even correct it because that's silly. I want to add 7 to the negative 4. So that way it's between 0 and 6. So we get 3x equals 3 mod 7. And now granted, this is kind of silly. You can probably guess what the answer is. Spoiler, it's 1. But in any case, I want to get a systematic way for doing this. If it's not easy and if it's not obvious and you're dealing with larger numbers, how would we do this? Well, last time, before the pandemic, we learned about the Euclidean algorithm. And so let's apply the Euclidean algorithm, or EA as the cool kids call it, like EA Sports, that's what it actually stands for. We want to apply that on, let's say, 7 and 3. Because I want to find the inverse of 3 mod 7. That's our goal. Well, so let's do that. The process ends pretty damn quick. 7 is equal to 2 times 3 plus 1, and after that you get a remainder of 0. But the thing that we care about is ending in 1. So I want to point out we can do some sorcery here, and that is I can subtract this over. And when I do that, like really, I want to write it as 7 minus 2 times 3 equals 1. But even more specifically, I want to write it as 3 plus negative 2 times 3 equals 1. Trust me, there's a reason for this. Don't actually multiply anything out. I know it's 6, you know it's 6. So after that, let's take mod 7. Remember, when you do mod something, whatever that is, mod 7, 7 becomes our 0. So if I had 7 times anything, or plus 7, it's all 0. So all we're left with is negative 2 times 3 is congruent to 1 mod 7. That would mean that negative 2 is 3 inverse mod 7. Because again, what's an inverse? It's whatever you multiply by to get 1. Well, in this case, negative 2 does that. But again, your parents raised you right, so you're not going to leave it like that. Instead of negative 2, I want to correct it, add 7, because that's what we're modding by, and we get 5. So 5 is 3 inverse, 3 is 5 inverse. Again, these are all for these specific problems. Like every time you change the modulus, we have to run through this process again. So 3 inverse is 5, 5 inverse is 3, mod 7, mod 7. And then we can solve this problem up here. Like, I can multiply my 3 inverse on both sides. And, I mean, alright, and admittedly, even if you didn't know what 3 inverse was, 3 inverse times 3 is 1. But let's say, since you do know what it is, 3 inverse is 5, so you have 5 times 3, mod 7, we get 15, and 15 mod 7 is the same as 1. Again, you don't need to do long division. If you want to, go for it, but realistically, you just subtract 7 a bunch of times, and you'll get 1. And so our answer is 1. Alright, but here's the thing. The problems in the book are a little bit more obnoxious, so I want to do one that's a little bit longer. Just bear with me. So, our process for this will be process for finding an inverse, is we want to use the Euclidean algorithm on the two numbers. But smaller mod the larger always. But in any case, so use the Euclidean algorithm on the numbers given until the remainder is 1. And then, our next step is the annoying part. We're going to unpack that all. And we're going to follow a process, which I'm going to show you in a moment, but just so you can have it summarized. Substitute, distribute, combine like terms. And, not to be annoying, but when multiplying, when multiplying 3 things, only multiply the first 2. So, for example, if I had 2 times 3 times 5, I would write that as 6 times 5 and leave it like that. It's very important that we follow this to the T. There might be quicker ways of doing this in certain special cases, but considering that I'm unaware of that, the problems I'm going to give you are going to be reasonable if you follow this. So, alright, here we go. Let's say we want to find 18 inverse mod 25. So, the first thing we want to do is the Euclidean algorithm with 18 and 25. So, what do I want to do? I want to say 25 equals what times 18? And I'm going to be pretty militant about writing it in this order. What times 18 plus what? So, well, it's 1 times 18 plus 7. Okay. And now we're going to do the same thing with 18 and 7. 18 is what times 7 plus what? So 2 times 7 plus 4. And now we're going to do it with 7 and 4. I don't know if any of you guys meditate, but this is kind of like that. It's nice and relaxing. You know, let your mind wander. So finally, 4 is equal to 1 times 3 plus 1. My neighbors probably think I'm psychotic talking to myself. I mean, they're not wrong, but anyway. So, we're going to unpack this now. So, I'm going to end up using each of these equations in reverse order. So, first, I want to take equation 1 and solve for 1. And how do I want to do that? Well, I'm going to write this. 4 plus negative 1 times 3 equals 1. So, what did I do? I subtracted this over, the 1 times 3. So, I'm going to write it out here, but then I'm going to erase it. So I subtracted that over, the 1 times 3 together, and then I'm just going to write, instead of saying minus 1 times 3, I can write plus negative 1 times 3. So, in any case, again, there are reasons for this that will be revealed shortly. Okay, so we use equation 1. Yay. So, here we go. Substitute, distribute, and combine like terms. I want to substitute in the 3. So first I solve for the 1, I got that. Well, now let's solve for that 3 and substitute. So, down here, I'll just write, we're going to have 7 plus negative 1 times 4 equals 3. So, in place of the 3, I'll use a different color. We're going to write this in parentheses. So we're going to have 4 plus negative 1 times all of that crap. 7 plus negative 1 times 4 equals 1. Okay, substitute. Now I want to distribute. Again, keep in mind our rule over here. If I'm only multiplying 2 things, just leave it alone. Don't do it. Because ultimately, if I didn't simplify all this, I know what I'm going to get. I'm going to get 1 equals 1. That's not helping. You'll see it in the end, I promise. So, distribute the negative 1 times 7. And now we have negative 1 times negative 1 times 4. Like I said, multiply the first 2 things. So I'm going to have negative 1 times negative 1 is 1 times 4 equals 1. We distributed. And now combine like terms. Well, I know this seems silly and weird, but in any case, let's imagine that's also 1 times 4. If I add 1 times 4 plus 1 times 4, I'm going to get 2 times 4. Okay. And so, yay, we did it. Now we want to do the same thing for this guy. Same process. So, I want to substitute that in. Well, what am I substituting? It's going to be 18 plus negative 2 times 7 equals 4. Don't worry, the next class is not as intense. Alright, so I'm going to substitute that into this 4 here. So we're going to have 2, and I'm going to use a bracket. 18 plus -2 times 7, parentheses, plus -1 times 7 equals 1. Okay, we substitute, now distribute. Again, remember our rule of multiplying, so we're going to have 2 times 18 plus 2 times -4 is, try that again, math is hard. 2 times -2 is -4 times 7 plus -1 times 7 equals 1. Combine like terms. Well, now it's a bit easier. -4 times 7 plus -1 times 7 is going to be -5 times 7. Okay, oh god, we're almost done. So, finally, you guessed it, we're using that last equation. We'll use green, why not? So, we're going to have 7 equals 25 plus -1 times 18. Alright, well, so in place of 7, I'm going to write that whole mess. So we have 2 times 18 plus -5, bracket, all that other garbage, 25 plus -1 times 18 equals 1. And so now, again, distribute. -5 times -1 is +5. And finally, combine. So I'm going to scroll down a little bit. There we go. So now combine like terms. 2 times 18 plus 5 times 18 is 7 times 18. Alright, oh my god, by this point you have to be wondering, why? Why are we doing this? Why did this help us out? Well, first of all, don't yell at me. So, in any case, if we take mod 25 of both sides, what are we actually left with? Well, like I said, 25's are 0, so you have 0 times -5 is 0, who cares? The only thing I'm left with is 7 times 18 is congruent to 1 mod 25. Okay. Well, you should be jumping for joy. If you're not, think about it. We were trying to find the inverse of 18, meaning we wanted to find what times 18 gives you 1. We did it. It's 7. So 18 inverse is 7 mod 25, and 7 inverse, not that we care, is 18 mod 25. So one last equation we might as well do. So knowing that, let's say we had solve, I don't know, 18x plus 4 is congruent to negative 10 mod 25. I sure hope the answer's not 1 or anything stupid. But in any case, we'll find out. I know I'm excited. So, subtract 4 on both sides. We have negative 14 mod 25. Again, I don't like that. I don't want to keep it that way. So what I want to do is correct the negative 14. And all you have to do is just add it. So if we add it, we end up getting positive 11. Okay. And again, what are we doing with both sides? Really, we're multiplying by 18 inverse. What is 18 inverse? It's 7. So we're just going to be left with x is congruent to, well, 7 times 11 is 77, but mod 25 is going to be, well, I don't know, 77 minus 50 is 27, hopefully. I get nervous while recording these. Oh wow, oops, we can keep going. No one saw that. 2 mod 25. The answer's 2. Alright, so I've also posted a link about RSA encryption. It gives a better explanation than I ever possibly could. So I would love for you guys to watch that. It's really not that long, I think it's about 10 minutes. But then we can discuss encrypting and decrypting next class at the beginning, on Wednesday. Alright, have a good night, guys.